Hi everyone, this is your math guru. In this video, I'm going to show you how to apply the trigonometric ratio and the Pythagoras theorem in solving the following. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. In the diagram below, angle DFE is equal to 90 degrees, the line DE is 1 unit, and cos E is equal to K. Determine A, the line EF in terms of K, B, the line DF in terms of K, C, express tan E in terms of K, and D, prove that sine D is equal to cos E. Starting with the first part of the question, angle DEF is 90, that's given in the diagram, line DE is 1 unit, and cos E is equal to K. So I have, using my trig ratio, the acronym SOHCAHTOA, which means that the sine theta or sine of the reference angle equals opposite over hypotenuse, the cos equals adjacent over hypotenuse, and the tan equals opposite over adjacent. So if we've been told from the diagram that cos E is equal to K, what I have is cosine or cos E is equal to adjacent over hypotenuse, and that's equal to K. Because K is a whole number, that will be K over 1. If I go back to the diagram, E is my reference angle, so I'm going to highlight that. And what that means is the line facing the reference angle, using that with my arrow, I have line DF, that will be the opposite side, or my O. The line facing the right angle, or the longest side, is my hypotenuse. That's my H. And the last side, a triangle has 3 sides. The last side is my adjacent, or A. So therefore, going back my statement, cos E equals K, because my reference angle is E, my adjacent will be K. In this case, that's EF. So I have that as the line EF over then my hypotenuse, that's 1. So EF, that's the first part of the question, that's A. Determine EF in terms of K. What I have is EF, based on my ratio, K over 1 equals EF over 1, EF is equal to K. For the B part, we're to determine the line DF in terms of K. Because it's a right angled triangle, I'm going to use the Pythagoras Theorem, which states that the square of the longest side, that's ED in this case, is equal to the sum of the square of the other 2 short sides. So we have ED squared equals DF squared plus EF squared. ED squared is 1 from the diagram, so I have 1 squared is equal to DF. That's the missing side, DF squared, plus EF. EF from the diagram is K. That's what we got from the first part of the question, so we have that as K squared. Making DF the subject of formula, we have DF all squared is equal to, using the balance method, I'm going to subtract K squared from both sides, or move K squared to the other side. Going to the other side is going to be negative, so I have 1 squared is 1, minus K squared. Therefore, to find DF, you find the square root of both sides. The square roots will cancel the square, so therefore my DF in terms of K is equals square root of 1 minus K squared. The next question says we should express tan E in terms of K. Tan E is equal to, using the trig ratio, tan is opposite, that's O over adjacent A. Opposite is my DF, so we have that as root of 1 minus k squared divided by adjacent. If I go back, EF is k. So therefore, we have tan E equals opposite over adjacent, which is the same as df over EF, and that's root 1 minus k squared, all divided by k. The D part of the question says, prove that sine D is equal to cos E. So sine D, my reference angle is changing to D. And once my reference angle changes, what that means is the labeling of the side will also change. The side facing the new reference angle is my opposite. The last side will now be my adjacent. The only side that remains the same is my hypotenuse. That's line ED, or the line facing the right angle. So going back to the D part of the question that says, prove that sine D equals cos E, my sine D equals, using the trig ratio, opposite over hypotenuse. So I have opposite over hypotenuse. The opposite for the reference angle D will be line EF over hypotenuse, that's ED, and that's 1. Line EF is equal to K over ED, that's 1. So therefore sine D is equal to K. Cos E, I have cos E. Cos for my trig ratio is adjacent over hypotenuse. Note that my reference angle now is E. So I'm going to highlight that. My reference angle is no more D, it's E. And what that happens is my adjacent and my opposite changes based on my reference angle. So the side facing the new reference angle will be my opposite. The last side is my adjacent. Because cos is adjacent over hypotenuse, I have that as EF over hypotenuse ED. And EF on the diagram is K over ED 1, which is K. Therefore, I've been able to prove that K is equal to K. Therefore, sine D is equal to cos E. Thanks for watching. Bye.